Cool. All right. So, and if you could just, shout out if you can't see something. So we're going to talk about isolines. Iso means equal. Oh, equals equal. That's cute. It's not a real good sentence, but iso means equal, and then a line is obviously something that is the shortest distance between 2 points, unless you're on a globe. So contour lines show equal elevation. There are also things called isobars, which show equal barometric pressure. There's isotherms that show equal thermal pressure. There's iso tac something or other. It starts with a T that shows equal wind speed. And so this is kind of piggybacks on our discussion of the weather station model, because we can use a weather station to draw isobars and isotherms, and we can also look at tachy, whatever it's called, isotachanometry or something. I don't know, iso something, which is wind. Sometimes I just make up words because I can't remember what they are. So, all right, so we're going to start by talking about contour lines. And of course, there's some description here, but the idea is if we had a 3-tiered cake and each tier was a different flavor and but the same height, but a different size. If we looked at it from the size, our cake would look like this. If we looked at it from the top, it would look like this. And so what contour lines show is those elevation differences between each of these layers, as if we were looking at the Earth from the top. So the first thing we need to do is it says, observe the cake. What do you notice about each of the 3 layers? Do they cross or mix? Are they parallel to one another? Is the cake symmetrical or asymmetrical? So let's deal with each one of these questions separately. So we'll start with, what do you notice about the 3 layers? Don't all talk at once. You're like noise canceling headphones out there, man. Come on.
Oh, sorry. I didn't realize we had to say it out loud. I was starting to type it all out. I was so ready to okay, here I am typing. Okay.
Well, what did you type?
Okay, I was beginning okay, all the layers are different sizes.
Okay. Different sizes. But same thickness. So this is the same as this, which is the same as this. But yes, they are different. So they don't cross or mix. Are they parallel to one another?
Yes.
Yep. So, yep. This is the Pitt's way of doing things because I'm using a pen. If you're not using a pen, then you have to write, yes, they are parallel. And then is it symmetrical or asymmetrical?
Asymmetrical.
It is asymmetrical, remembering that if we were to cut this cake in half, it would need to be the same on both sides. And so I suppose if I cut it here, it's still considered asymmetrical because it's off to the side. But so yes, it's asymmetrical. So I'm just going to circle it. Ha ha! All right, it says, assume each layer of the cake has a height of 6 inches and that the bottom of the cake is at 0 inches. Label each line shown on the right figure with its height. So we're just going to come over here and we're going to say this one's 0. So if the bottom of my cake, my chocolate cake is 0, then the bottom of my vanilla cake is 6. And if the bottom of my vanilla cake is 6, then the bottom of my berry cake is 12. So that's what we do there. What is the total relief of the cake? Well, oh, 0 is the bottom, 6 is the bottom. Oh, Yeah, and then 12 is the bottom, but they want to know the total relief of the cake. So that's the difference between the bottom, which is 0, and the top, which is actually 6 inches higher. So that would be 18 inches. So I labeled this wrong. I shouldn't have done it that way. We can't know that the bottom of the cake is 0 pits. So that on this would be 6, and then this would be 12, and this would be 18. I'm like, I know I'm doing something wrong. You know, you'd think I would have practiced this. Okay, I did practice. I don't know. I don't know what it is. I've been spending too much time learning about the earth, and I'm all verklempt about it. So I apologize. Our paper's now ugly. You label the top of the hill, not the bottom. So again, 6, 12, 18. But it's still 18 because the bottom, this is 0, and the top is 18. So 0 minus 18 is 18. So, all right, let's see. Now imagine that this cake was a hill. Which side of the hill has a steeper gradient? So what they're asking us to do is imagine that instead of being this a cake, that this was a hill. So which side of our cake is steeper? Well, I'm going to go with the one on the right side. And the right side. And one of the things about isolines is there are like rules to them. They never cross each other. They are always, drawn at the same interval. They, show in this particular case equal elevation. But there's another rule, and that rule says, and you can kind of see it in our little picture here, if the contour lines are far apart, then the gradient is less steep, right? So if I was asked to climb this, it would be like steps. But if I, was standing here, I couldn't really step off. I could jump off, I suppose. So it's very steep on this side. And so if you look at the lines, the distance between the lines here, they're closer together. So we're going to say closer contour lines. All right. So topographic maps show lines for selected elevation, otherwise it'd get really confusing. Typically, it's like on a 10-foot or 20-foot or something like that. And it's usually like written out, like near the scale bar, it'll tell you what the contour interval is. And that's the word that we kind of talk about. So the contour interval is the distance between contour lines. And a lot of times, especially on topographic maps, you have what we call index contours, which are going to be a darker color. But the interval is still the lighter bands in between. And so the contour interval is the distance between, not the index contours, but each contour line. Not the distance, sorry. The elevation difference between the contour lines is called contour interval. So it says, refer to the contour lines that you labeled on the right side. What is the contour interval of this map? And so the easiest way to do it is just to subtract. Well, let's see, this is 6 and this is 12, so I'm going to go with 6. All right, so the next thing it wants us to do is do a connect the dots activity on this map here. So it says, remember, contour lines are elevation lines that are constant. They will never cross, change, or disappear. A great way to learn the rule of contour lines is by connecting the dots. So we're gonna make it kind of fun and easy. Below, you'll find an image that consists only of elevation points, so you'll need to connect the dots. This can be challenging as the elevation points are even, odd, and everything in between, so you have to interpret the data. Sometimes you have to figure out where a specific number belongs that you cannot find. As an example, contour lines for 45 and 40 have been drawn for you. Note how each of these contours never crosses and always maintains their value. Hint, you will observe a set of 10-foot contours that run southwest to northeast. That is a river. Complete the following contour lines for 35, 30, 25, 20, 15, and 10. Okay, so here we go. So all we're going to do in this particular case is connect the dots. The important thing to remember is that you want to keep numbers that are higher on one side and ones that are lower on another. So this line here is 40. Okay. So the next one we're going to do is going to be 35, right? So in order to keep 35 there, we have to make sure that these 36 and 38 are on the inside. So this, we're going to start like this. Oops. We're going to start like this. Very good, pen. Okay. So, and then 36 is higher than 35. So we're going to have a line in between these. And then same thing here. And then here. And here. Here. So we have to, what they say, interpret the difference. So we have to be in between these two. And then 30 is, okay, so we're going to come around here, right? And oh, here's another one here. Woohoo. Oh, then we swing this way. Pick this guy up. Because 32 is lower than it, so it's got to be on the outside. And there, and here. And here. 38 goes on the inside. So like that. Okay. So then you're going to do the one for 30. Same thing. So it's going to be between these two because it's 28. So it's going to be to the right of the 28. So this next one's 30. Oh, I like to label them kind of off the map. Usually I use a pencil, so I can erase it afterwards because you're not really supposed to. But I'm trying to be real right now. Just kind of connecting the dots here. Oops, 32 goes on the inside pits. 30, 30, 30, 30, kind of like that. So then we go again. The next one's 25. Oops, boo-boo. Uh-oh, I made a oopsie boo-boo over here. Oh, issues all over here. This is why we should use erasable things, because there we go. 5, 25. Part of it is that I have to keep telling myself what the number is that I'm drawing. Like, you know, like squirrel. Now, I will show you that up here, there is 2 sets of contours. There's actually a river that comes to see here where there's like 8 and 8 and 10 and all those. So let's do the 10-foot contour line. So this is going to be one side of my river.
Can you move it down just a little bit, please?
Nope.
When you get the chance?
Just kidding.
Thank you.
You're welcome. Oh, you know what? I don't like that line. Let me do it again. Bad interpretation, Pets. Some of them need to be on one side of the river and some of them need to be on the other. So I'm glad it wasn't down far enough that you could see it. Aha! So that's why I have a note in my notes that says do the 10-foot contour because it's hard. All right, so I'm going to draw one line here and one line here because I'm going to have two contour lines because there's a river. So you see where these 8s are? That's like our delta. It's like opening up a little bit. And so I'm going to draw two different contour lines, which is going to be real fun. So instead of like zigzagging like this, I'm going to just pick one on each side of my river. So I'm actually going to draw both lines at the same time. Probably could have done it a little differently, but there's another one there. That's okay. And then we'll take this guy and bring him over here like that. So I did them at the same time because the notes told me, you know, that there's a river there. So, and you're like, well, what about this 10? Well, that's going to be another contour line. We're not sure who it connects to. It's off the map. So we just leave it you know, I mean, I guess if you wanted to, you could, you know, draw a line through it, but that's kind of silly. So I would just leave it alone. Same thing with this one. We're not sure how that one plays in. There aren't any more, so it's not like there's an island here or something. And you usually don't have like straight lines. So this could be like the beginning of like a mesa or something. There could be like a little 10-foot, you know, depression right here or something. We don't know because it's off of the map. So that's good enough like that for our 10-foot. So that leaves you with 2 lines on this side of the river and like 3 or so lines on this side of the river to do. And if we have time, we will go back and do them. But for now, hopefully you guys understand how to do it. Maybe? Okay. Well, we should have time. I just don't want to. Okay, so what is the contour interval? It is 5 feet. Woohoo! How do we know? Well, because this is 5 feet higher than this, which is 5 feet higher than this, which is so. All right. So the next thing we're going to talk about is relief. And relief is like another name for slope. So it's the difference between the high and the low. It's, you know, sorry, profile is, no, relief is the difference between the high and the low. And so on our next one, we're going to look at drainage because a lot of times it has to do with drainage features. So running water follows the path of least resistance. And so the next map is of something called the Three Rivers Mountain. So that gives us a hint. There are going to be 3 rivers that are drawn on it. It says, observing the patterns on the map. So let's look at the map. So observing the patterns on the map, you see that there are 3 rivers on the map, you know, because of these V-shaped things. So cool thing about contour lines is they form a V shape whenever they intersect a river, and the V always points upstream. So I'm just going to put some notes over here. B is upstream. Okay. So observing the contours take this shape. Yeah, I already said that. Use a blue colored pencil to draw in each of the 3 rivers. Oh, cool. I have one. You can use a blue pen if you have one. If you don't have one, you can use a blue highlighter. If you don't have that, you can just, you know, and we'll put little arrows so that we know that the river is going this way. On the top of the mountain, draw a smaller contour line using a pencil to replicate the bottom of the lake. So we're going to say this is our lake. And we know that the lake must be deeper than the 180-foot contour. Otherwise, it wouldn't be a lake. It would be a mesa or something. So we're going to add little tick marks to this guy here to show that the elevation went down. It wants me to use brown, but my brown pen looks just like my black one, and I already have it in my hand, so it's okay. They don't. Your teacher's fairly, nice about what color you use. The important thing is that you put them on there. So these little things, they're called hatchers, which tell you as the map reader that instead of this being higher, it's actually going to be like, it's actually technically, it's sloping down to the one below it. So technically the bottom of the lake in this particular case is 160 feet. So it asks us, so 160 feet. And we know that because this is 180 and the hatcher marks say that it's going downhill. So this is going to be a lower contour versus a higher contour. If we didn't put the little hatchers there, then this would have been 60 feet higher in the top of a mountain. So the other interesting thing to make sure of is that you don't go into the lake with your river. The odd thing is that most areas are going to drain to the lake, but in this particular map, all of the rivers are pointing away. And so the only way this bad boy gets filled is if water falls like directly above it or on the slope going down to this level here. The rivers don't actually flow out of the river. It's a basin more than anything. So to call it a Three Rivers mountain is not appropriate because it's, I mean, I guess it's a mountain until you get to this lake, and then it looks more like a caldera than anything else. All right, the next thing is something called a topographic profile. And a topographic profile represents a cross-sectional view along a portion of a particular map. So we're going to actually make one. If you go to Google Maps, which I think it has us do, click directions, blah, 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 sketch the profile of a bike ride from your address to your college in the space below. Okay, so here we go. Let us switch. Do the old switcheroo. Let's see here, switching. Switcheroo, switcheroo, do, switcheroo, switcheroo. Okay, so we will go to Google Earth. No, Google Maps. That's what it told us to use, right? Yes. All right, so maps.google.com. Okay, so we're going to put in a profile from where we are to the school. So we'll start with Victor Valley College. Oh, you got to spell it correctly. It helps sometimes. All right, so there's our little spot. And let's say we live, oh, I don't know, over here in Oak Hills. Why does it say the Metrolink station in Fontana? Well, that sounds like fun. Okay, we're going to ride our bicycle from the Metrolink station in Fontana to Victor Valley College. That looks like it'll be fun. Okay, not really, but well, let's switch it around. And we're going to ride our bike so we can see the profile. So this is what the profile looks like. So this is what you would draw. If that's, so if instead of living at the Fontana Metrolink station, oh, I don't know, you lived in Apple Valley. Sure, just say Apple Valley. Let's see where it goes there. Okay, cool. Again, that looks like fun. I don't want to go that way. I don't want to live there. Let's say I live over by Granite Hills High School. All right, why isn't it showing me my profile now? That wasn't very nice. let's say I walked. Where's my profile? Oh, I have to pick which trail I'm taking. No, it still doesn't show me. That's not very nice. You saw that it showed, right? Like, hello. I give up. I'm mad now. Going back to the fake it till you make it, Pitts. Okay. Go back to my other share because it's being dumb. Poo-poo head. All right, so draw a topographic profile if you cycled. All right, it looks like this. And then I had to go way up and then back down a little bit like that. There's my topographic profile. No one's ever going to know the difference. What is the relief between your address and the college? Oh, I was at, let's say 1,400 feet, and now I'm at 3,000 feet. I don't know. I wonder what the elevation is. Hey, Alexa, what's the elevation in Victorville? Pretty darn good. I'm just going to say it's 3,000 feet and call it a day. Okay, cool. There we go. Okay, I did that. All right. Oh. Oh, I wasn't supposed to draw it there. I was supposed to draw it here. All right, so the relief is going to be 3,000 minus my 1,400, which is something with a 6 in it. 26. 6 is 2, 16. 1,600 feet. All right. Refer to figure 211. That's this guy here. All right. So we're referring to figure 211. And now we're going to construct a profile of this particular hill. So the way you can do this is like with an index card or just a piece of paper. And we are going to mark where each of these contour lines are. So we'll make a line here where our first line is. So we're just going to line our paper up, or our index card or whatever you're using, and I'm literally just going to put a little dashy line every time my contour line goes under my paper. Okay. And in this particular case, this is 0 feet. So this would be 0 here, and this would be 0 here. Right. So now we look at what is our contour. Contour is 20. So this would be 20 feet, 40, 60. This is the other side of the hill, so that's 60. I don't know what that one is. We're gonna have to go this way. This one's 20. This one's 40. This one looks like 60, 80, 100, 100, 80, 60. So far, so good. Okay, cool. Now we're going to come down here and we're going to transfer these dots. So I'm going to start at 0 because that's the start of my line, this part right here. And we're going to essentially draw the contour between these along this line across the entire mountain. So 0, 0. So I put a dot on my graph here. And then next one's going to be 20, and then 40, and then 60, 80. So I'm literally just going straight up and putting the mark on my paper. Oops. Got a little excited there. 40, pits 40, 20, and then back down to 0. All right, now this is a hill. So we like to interpret a little bit in between. The top of this hill is less than 120 feet, but greater than 100 feet. So we can make it anything below that. So we're going to put our peak here. I'm just going to say that's the peak of my hill. Okay. These two here are at the same elevation, but this could have gone down as long as it doesn't go down below 40 feet. So I'm going to draw a little valley in here. Not a big one, just a little one. Okay. Oh, oops. Valley doesn't go there, pets. Valley goes here, right? Yeah, valley goes here. Hill goes there. That's this hill right here. And then we're going to slope down this way. Then I get something that kind of sort of looks something like that. So I have this peak and then this cute little low valley and then another little knobby hill, and then it slopes back down the other side. Now it says, now that you have completed your profile below, you will find a few more questions regarding the observations from the map above. What is the highest elevation possible on this map? Well, it starts with a 1. Highest elevation is going to be 119 feet. Why? Because if it was 120 feet, there'd be another contour line. Right? And so we know, because this is 100, that because there is no contour line there, the highest elevation possible on this map is 119 feet. What is the lowest possible elevation for this map? Well, in this particular case, we're just going to say 0. Contour maps usually don't show bathymetry unless they say they do, and bathymetry would be below sea level. So, yeah, so we're just going to say 0. All right, it says, let's see, the next thing says, locate the letter A on our map. What is its elevation? So here's A. So what is the elevation of that spot? Well, it's on a contour line. So all we have to do is figure out which contour line it's on. So let's see here, 0, 20, 40, 60. It's on the 60-foot contour line. So it's got to be 60 feet. And then B is not on a contour line. So it's going to be between two contours. So in this particular case, it's between 20 and 40. And I don't know, I'm just going to say it's 30 because it sounds like a good option. I could say it's only, 29 or 27 or something, because it is closer to the 20 than it is to the 40. It's not really halfway in between. Close to halfway in between. Yeah, I would just say it's 30. So again, we can look at this and we can see that steep side again. The contour lines are really close together right here. That's because we have a nice steep hill and then not as close together over here. So not as steep. So now we've done ISO contour lines. And so the next thing we're going to look at is ISO bars, which work the same, only this time it's barometric pressure. And so we're going to have a little more interpolation on this one, I think, if I remember doing this correctly. No, I lied. They are only the numbers that we have, which is even more fun. So if you recall from our conversation before about what was the word I was thinking of? Oh, weather station models. We have a, it's going to be between 950 and 1050. But the weird thing is that standard pressure is 1024 point something. So, so normal pressure on our planet is 1020, sorry, 1024, 1012, 1012, 1012, 1012. Sorry. So that's like normal on our planet. And so that definitely has to be a contour line, and sorry, an isobar line. And they're on the 4s. So the contour interval for isobars is always 4. So in this particular case, we're going to start at 1,000 and we're going to go up until, you know, wherever we have to. I think, let's see, there is no thousands on this map. I see 1,008. So it looks like there's a cell right in here. Right? So 8 plus 4 is 12. So this one, it's about making weird shaped circular looking things that connect the lines. So we'll do one over here. Didn't really quite pick that up very well. There we go. Okay. We have a 1020. Oh, look at that. It's another cell. This guy like this. This looks ugly. There. Now it's not as ugly. Still kind of ugly, but. So this one's nice. It's, in my opinion, a little easier because the only numbers that are there are the numbers we're given, are the only ones we have to use. So unlike the contour line one where we had to like interpolate between 2 values, that's not to say that when you're given an opportunity to do something like this, that you won't have to interpolate between 2 values. But it's just an idea. It's just to show you what isobars look like. And so it says label each isobar with the appropriate value. So so we'll label this one 1024. You only have to label it once. 1020, 1016, 1016, 1012, 108. Sorry, 1008. And here it says that, you know, 10,008 would be labeled 08 and 992 would be labeled 92, but we're not going to do that. So we're just going to label it with what it is because I already did. We'll see who listened to my lecture. That would be the 2 of you, and who listened to it on Zoom later on, and who didn't and just follow the directions. I'll be like, you didn't listen to my video because I told you to label the whole thing. So make sure you label the whole thing. I'm trying to see how many people are actually listening to these things. Who don't come. That is, obviously you're listening because you're here. All right, so it says isobars can be used to identify highs and lows. The pressure is greater than the surrounding air. The low pressure is lower than the surrounding air. Label the center of the high pressure with a large blue H. Okay. Large blue H. Boom. Label the center of the low pressure with a large red L. Okay, cool. High pressure regions are usually associated with dry weather because as the air sinks, it warms and the moisture evaporates. Low pressure regions are usually bring precipitation because when the air rises, it cools and the water vapor condenses. Shade in green, the states you would expect to see rain or snow. So where are we going to see rain and snow? In the areas where there's precipitation. Where is the areas of precipitation? That would be those areas that are under a low pressure system. So we're just going to shade, oh, I don't know, we'll shade in these guys here. And then it says shade in yellow, the states where you expect to see clear skies. And again, that's going to be over our high pressure. So we'll just put it in the center. You could expand it a little bit, I guess. Fine. We'll put it out here too, because it sounds like fun. Kind of makes sense, except for today. Although you guys probably have clear skies. Are you guys up in the high desert? Is it clear out? It is completely cloudy and misty and gross here. I'm down in the Diamond Bar area. Obviously, you can tell from my background. All right. And just to be fun, we'll shade this out here too. All right, there we go. Good enough. All right. We did that. We did that. In the northern hemisphere, the wind blows clockwise around centers of high pressure. So draw arrows around the high pressure on your map to indicate the wind direction. So the wind blows clockwise around high pressure. So that would be this way. This way. Okay, and then it's going to be counterclockwise. So that's going to be this way and this way. All right, cool. The next one is an isotherm map. So this one, we're gonna, again, make a map based off of temperature-y stuff. It says start by drawing the isotherm for 40 degrees, and 40 degrees sounds like it's a cold temperature. So we'll connect the 40-degree temperatures like this. Must be in Celsius because although I guess it could be in Fahrenheit. Now do the same for the 50 and the 80 and do the same for 50 to 80 in 10-degree increments. Okay, so here's my 50. And we have a 30, 20. Uh-oh. That's a 30 pits. Could have warned me. We tried to warn you. Okay. And then we have our 50. Oh, where does it go? We'll do that, I guess. 60. 70. 80. 90. Just make it up as I go. Then shade between the lines as seen above. Oh, Jiminy Cricket. Okay, so I guess the 90s are supposed to be in the red areas. And 80s, we'll make it orange. Yellow. I'm going to run out of colors. So we'll make this one orange, yellow, and then we'll make the next one yellow, yellow. You get the drift. You don't need colored in. Again, let's see how many people listen to Pits and actually, so. All right, see, now we have time. We have 10 minutes. Look at us. All right. We'll go back to this guy. I don't want to do it all for you. You won't know how to do it. All right, I'll do it all for you. Here we go. The next, let's see, is 20 foot, right? Oh gosh, there's this big old 20-foot thing right here. Now we'll just do the inside ones. Oh, dang. 20-foot one's hard. I should give myself a note to do the 20-foot one too. Remember, we're keeping the numbers that are higher on the left side of our line and the ones that are lower on the right. Huh?
Oh, there was a 23 over there.
Yeah, that means it should be on the right side of my line because it's higher. It should be between 20 and 25. Did I miss one? No, that's right. That's cool. That's cool. Yeah, that should be okay. We could even do this if we wanted to. Make it look like there's a mesa over there. A lot of this is subject to a little bit of interpretation. A lot of times contour lines tend to follow each other, kind of like we have over here. This is kind of weird. I don't know what the heck's going on over here. The interesting thing about contour lines is this is how they mapped all of the United States from aerial photos. And then they would send out survey parties to check and make sure that they were accurate. So they would take something like this and they'd go, oh, well, these all look like they're the same elevation. So, you know, and then they'd go out and ground truth it and be like, oh, no, that wasn't quite right. That's not a mesa. That's actually, there's a hill here. And then, you know, I don't know. This is weirdness going on down here. All right. So now we go back up here. And so we go 15. 15, 15, 15, 15. We have 20. 20, 20, 20, 20. Like I said, if I say the number to myself a lot, then I remember what I'm drawing. 25, 25, 25, 25, 25, 25, 25, and then 30, 30, 30, 30, like that. And I could also, I guess, put the river in here, I suppose. So there, look at that, all done. Woohoo, yay, us, woo! All right, let me double check and make sure that's all we have to do. I think it is. I'm pretty darn sure it is, but I'd hate to let you go and then be like, oops, forgot to tell you about this. Yep, that's it. Not even a quiz or a test. Oh, the discussion has not been posted yet. I will get that up quickly. Gotta have something for y'all to talk about this week. Oh, I know what I'll have you talk about. Let's give them something to talk about. Something to do. A little mystery to figure out. I'll get it in there. Let's see here. Discussions.
Was
Should be
the
in-
extra credit for this week as well? That you mentioned earlier?
There's only one extra credit is due on May the 4th. So there's stuff going on this week. There's a couple of things going on next week related to Earth Day. And I wanted to give you time in case, you know, you got it kind of late and you're like, this whole week's planned for me, Pitts. I ain't got no time this week, that you could watch like a movie about Earth Day.
Because I haven't, okay, so it's not posted yet either,
What?
the extra credit?
It should be.
Okay, because I don't see it.
Okay, let me go back. That's more important than what I'm doing right now. I can get the, let's see here. In the module. Oh, where did I put it? You're right, it's not in there. Okay, so let me add that too. Let me add it to the module.
I'm
Extra
guessing
credit
the
Earth
extra
Day. There it
credit
is.
is the extra credit meant for those who didn't do so well for the midterm.
No, the extra credit is I don't even know where to put it. I'll put it under here. It's just it's Earth Day. I always do something for Earth Day.
Alright.
A number of the colleges that I work at have actual Earth Day activities that are sponsored by their geography departments. So for example, at Fullerton College, they called in a speaker. And so they're doing their speech this year on Zoom. And I was like, well, you know, in the past, it's been really hard for students to get there because, you know, they have things in their lives. But this time I'm like, hey, it's on Zoom. So as long as you have a cell phone, it's only going to last an hour. But then I gave them also other options. And I was like, yeah, it's not fair to only give it to one of the colleges I teach at. So I'm going to give it to all my college. No, but I always have an extra credit for Earth Day. And I will get that discussion. I don't know where it is, but I will find it and I will make sure it gets up there in the next 5 minutes. So I will find it. It's a challenge. And it's related to Earth Day, but I have to find it. It's like my backup one when I, you know, don't know what I want to have people talk about. It's my, it's the, hey, I'm tired of reading these. Let's challenge you to do something. Oh, that's not the class I'm looking for. Do, 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 do. Was it, when did I teach an intersession class? Oh, maybe I gave it to my intersession. Maybe I signed it to the wrong class. That's funny. I'm like, I know I gave it to somebody. Nope. It's a really good one. Man, maybe it was. All right, well, I'm gonna stop sharing for now, even though sharing is caring. Yeah, but everybody will listen to the beginning and the end.